Let me get this out of the way. Okay, I hope that everyone can see my screen. Yeah, perfect. So let's get this meetup started. Hi, and welcome to our global Rust and Tell, which started in Berlin and thanks to COVID is now worldwide. Thank you all for joining. Feel free to send texts or messages in the chat room and we will respond accordingly. So hi, my name is Bastian Gruber. I'm the co-host of this meetup. I worked with Rust for about a year. Now I'm currently not working in Rust. I'm a tech software developer, and I'm always curious about talking about Rust. So hi and welcome. And to Ryan.
Hi, I'm Ryan. I have also been working with Rust for quite a while, and excited for another edition of this Rust and Tell Berlin. You can find me on Twitter at Ryan_Levick if you want to chat about Rust. And I work at Microsoft, so if you're interested at Rust and Microsoft as well, then you can reach me there. So let's get on with it.
Cool. Hey. Thank you for joining. So this meetup and this format is about to share your struggles and ideas, hacks and projects, and it's all about Rust. So your project can have a few lines of Rust. Your whole project can be just 2 lines of Rust. We want to hear. This is about to share your learning experiences. This is not just for experts or for fully fledged out projects. This can be your self-help Rust group. So if you struggle to learn the language, feel free to come here and share your progress, and we will be here and listen and talk about it and help you out. I can go next. We also have a code of conduct since we started in Berlin and probably will go back to Berlin after this whole pandemic is done in a few years. So we follow the Berlin Code of Conduct. You can read it through on the berlincodeofconduct.org. Our 2 main important parts are we are here to learn. We all spend our free time here. So if you want to be a jerk, don't be it here, please. We don't have time and the mental capacity for it. If you encounter someone who is not treating you or like your friends here in a nice and respectful way, please reach out to us and we will handle the case with and for you. Since we are online and we chose to use a combination of Zoom, the old Matrix chat, which is now called Element, and we have a live YouTube stream. So in case you don't want to have any questions, feel free to go to YouTube and stream it live, and you can watch the talk or the whole meetup after we publish it in a few days. And the most important part is feel free to type the questions you have about the talk to the speaker in the chat box in Zoom, or use our chat to ask the questions you want to ask. This is definitely a Ryan slide. You're on mute.
Then I have to unmute my face and my audio.
Yeah.
Yes, this is definitely my favorite slide because it means we want any one of you to give a talk at this meetup. Whether you're a beginner or not, whether you've been doing Rust for 10 years or 20 years or 100 years, we want to see you here at this meetup to talk about your Rust journey. And if you have any questions about how to speak at a meetup, or if you want to riff on your idea a little bit with any one of us, then we're also happy to help. We just want to have you participate.
Exactly. Well said, as always. And we have a sponsor for today, which is the Global Rust Fest. And we want to tell you that the call for papers, the call for talks is still open until tomorrow at midnight UTC. So feel free to head over cfp.rustfest.eu and submit your talk idea and get picked and present a talk. If you don't get picked at the Rust Fest for your talk, feel free to come back to the Rust and Tell and present your talk here. And if you want to talk at the next year's Rust and Fest and want to practice, feel free to submit your talk here and you can practice the talk in front of an audience. So yeah, please submit your talk requests to Rust Fest and engage with the community there. We have 3 different talks today, thankfully. So, and thank you all for submitting. Our first talk is playing with Rust on 8-bit Atari computers. The second talk will be about building a video on demand server with Rust. And then our third talk is about what to do event sourcing. What do event sourcing abstracts look like? I'm sorry, abstractions look like. There was another window over the slide. Okay, as always, after the second talk, we will go into our breakout rooms where we have 10 minutes around to chat. We will have, let's see how many people we have in the Zoom conference, and we will split the rooms accordingly. And then you have the chance to talk one-on-one or one-on-4 about your favorite topics. And after the breakout rooms, we will go over to our last talk. Okay, so thank you all for coming and joining, being interested in Rust. Feel free to contact us at each day, at each time, over the Meetup platform, over Twitter, over LinkedIn, over email, and we are always happy to talk about Rust, about your talk proposals, and how we can help you to engage with the community. With this being said, let's head over to our first speaker, Raphael. Feel free to take over the screen and share your Rust experience with us.
Okay, so thank you very much for this introduction. I will try to share my screen right now. And I will open my cheat sheet here because, you know, it's better to be safe. Okay, I hope you can see the screen. So let me present what I have here. I did some pet project recently. So my idea was to play with Rust language on the very old Atari computers. In case you don't know what Atari is, these are the very old computers, actually even older than me, like 40 and some years old. And I started my software development career thanks to this machine. This is something about me and this nice picture here. I'm a Rust software engineer working full-time on Rust project since May this year. I'm also a retro computer enthusiast. That's why the talk was even created. And I'm also an 8-bit game developer, like some very indie games. One of these games you can see on my shirt, which is like shameless promotion. And you can reach to me on GitHub. I don't use Twitter or Instagram or TikToks and any other stuff like that. Okay, again, first some introduction, then live demo, which is always a little bit risky, but I hope this will be the most interesting part. Then we will take a quick look on the assembly language, and then we will check if it already, or if the project actually runs on the real hardware. So yeah, the goal. Create program in Rust, then do some magic stuff, and then run it on the Atari computer and have fun. You know, this is like basically only for fun. There's no profit behind it, but it's still worth the time. What were the possible solutions? I could build a dedicated LLVM backend, or I can just pick up the assembly that is generated currently by the LLVM and try to transpile it to 6502 assembler. The 6502 is the CPU that Atari computers run on. And apparently this transpile word, it exists. It's a shortcut from transcompilation, and it means transferring one source code in one language to source code in another language. So, you know, I need to spare my precious heartbeats because I'm not young anymore. So I decided not to go with the LLVM backend solution because it requires very much job to be done just to start playing with it. It's also a very complicated topic. So I decided to go with the other solution, so pick up the assembly and transpile it to the simpler CPU. I was hoping to use the 16-bit target, but unfortunately I couldn't make it to work, so I was forced to use the 32-bit target. And when you transferring the code from 32 bits to 8 bits, it's a little bit, it's a big gap, so it caused some troubles. Just a few words about the CPU that is powering Atari. It's very old. It has just 3 8-bit registers, where only one is actually capable of doing some operations like addition or bit shifting. It has 60-bit address bus, so it can address 64 kilobytes. It has no support for floating point, integer multiplication, division, and it cannot even directly move from one memory area to the other. You need to transfer everything through registers. It doesn't have the conditional move, so you only can do the conditional branches. So as you maybe expect, you need to write a lot of assembly code to have some simple effects achieved on Atari. Here's the example application. And the effect it provides is like the simple rainbow scrolling through the background of the Atari screen. What it does, it simply writes to the register that will halt the CPU until the photon beam reaches the right part of the screen. Then it will put another color to the background register, that it will increase this color, and again, jump to this label. So we can wait for another line to finish, change the color, and so on. So this is how we achieve it in Rust. I have created these byte wrappers for these 2 hardware registers, and then we just create regular code in Rust when we mutate X and constantly put it into the color register. So yeah, let's see how it works. So as you can see, I have this piece of code here. So first what I do, I need to generate the assembly. And it will execute. I will actually show you what it did. It executes the cargo ASM command with several parameters that I think are not that interesting. And what we get is the assembly code. Then I run another step, which means transpile it to Atari. And we are presented here with this a little bit longish assembler code, but this is compatible with the 6502 CPU. I will later explain what it is so long instead of being just 4 lines. Next step is to compile it for Atari. And we can run it on the emulator. And bam, yes, it works just as expected. you can see that we can create very simple programs in Rust in Atari. So while we are here, I can maybe play a little bit with the source. Let me check my cheat sheet. Okay, we can put another hardware register into play, which is the trigger for the controller, also known as joystick. And we can use the joystick button to stop scrolling of the rainbow. So we just read from this register. It will contain 1 if the button is released, and it will contain 0 if the button is pressed. So if you press the button, we will not scroll the rainbow. I will just quickly again generate assembly, transpile, compile for Atari, you know the drill, I need to do these 4 steps, and run in emulator. And now if I press this virtual joystick here on my keyboard, I hope you can see it, the rainbow stops scrolling. Okay, I will maybe show some other examples, which might be more interesting. Okay, let's put some text on the screen. As you can see, we will be trying to write hello Rust. And I need this empty loop just for the program to not go to some wild areas of the Atari memory. And we also need, yeah, the screen is a wrapper for the Atari screen, which is located in this specific memory area. And it has one function implemented, which is putchar, which is unsafe because we are writing directly to the hardware. But you can see that we can do some simple calculations in Rust and move them to Atari. So again, generate assembly. Transpile. Now do the compilation for Atari and run. Yeah, that's what was expected. And here's an interesting thing that the original Atari original assembler has only 13 lines. But if you generate assembly that is optimized for size, it actually gets 1 line longer. Oh, just a curiosity. And I will maybe show you one more example, the final one. Not to make you too bored. In this example, as you can see, we will be moving a little star on the screen. And we can introduce some conditionals. So if the position will reach like 1.5 line on the screen, we will reset it to 0. It will be very quick on the Atari. So let me do one change in the generated code. I will simply introduce a little bit delay between each jump instruction. Again, the usual drill. Yeah, that's working as expected. And why I wanted to show it to you that it also works on the conditionals, because like introducing every new functionality is actually very troublesome because you need to write a lot of code. I will show you that if I would like, for example, to clear the screen after the last star, so I would like to put another space at the exact position, I will generate the assembly. I will not be able to transpile it to Atari because the unknown opcode conditional jump is not yet supported by my transpiler. So the difference between x86 assembly and 6502 assembly is huge, and you need to take care of each of the opcode. Okay, so how all this works? Basically, the entire transpiling process is in this simple statement. We have the enumerate only to print the line number. And what I do is that I implemented this ASM line struct that is able to parse itself from string, from this string that represents the x86 code, and is able to simply display itself as the 6502 assembly line. So thanks to Rust, we all have all these nice enum types, enum variants that we can use for this. So for example, for each of these instructions, we have arguments, and these arguments have different meanings depending on the format. So I created the struct called arg, which can parse itself into numeric literal, virtual register, absolute address, sum address, or stuff like that. I will not explain the details about assembly. And here is all the parsing code that is necessary. And I have several simplifications in the code to allow me to translate it. Again, the higher level entity is the assembler line, which has following variants. It could be label and several different instructions that I decided and already implemented support for. Here is the parsing, which is very simple. And here comes the funny part, that thanks to the single match on our ASM line struct, we can generate various Atari code. So for example, if we see that we have an XOR operation, but only for this double, if two operands are virtual registers, and only if they are equal, we can simply put 0 in this virtual register. If, for example, I will encounter exclusive OR with some different type of parameters, I will just throw an error, and Rust will display for me that this operation is not supported, for example, for the literals. Then again, for the comparison, for addition, another kind of move, conditional move, which I had to simulate because 6502 does not support conditional move, as I said earlier. And I want to show you the trade-off I had to do. Yes, for example, this increase instruction, which is should be very simple one because it just increases single byte. But because I had to use all the registers as 16-bit, for this simple increase, which should look like that, just ink, I need to generate several lines of Atari assembly code. So that's why the transpiled code is a little bit longer than the one I showed you on the slide. And yes, that's basically this from taking a look at the source code. Let's go back to the presentation. Okay, so here is something how to generate assembly code from Rust if you don't want to use the websites like Rust Playground. You can install the cargo extension called ASM. It supports different kinds of assembly styles. You can work with different targets. This I already shown on the live demo. Okay, and here's the example transpiling process, and there are several remarks. Yes, this is what I mentioned, that instead of simply generating one ink instruction, I need to take care of adding one to the 16-bit variable. Another one, because on Atari, I cannot do, for example, this movement between memory. I need to transfer everything to registers. So at each instruction, basically, at each line, I need to start with saving the current state of accumulator on the stack, then do whatever is needed, and then pull the accumulator back to restore the original value that was stored there. So it also makes the code a little bit longer and slower. Okay, this I also described you on the demo part. I have the slide here just in case something is wrong with the live demo, but it went, I think, correct. And yeah, conclusion. Unfortunately, this approach is a dead-end street, as I think, because the difference between 32-bit language assembler and 8-bit assembler is too huge. And the x86 instruction set is a killer for this old CPU. To transpile, like without problems, I would need to emulate full 32-bit operations on 6502, which will create a lot of redundant code, which will probably even not fit in the 64 kilobytes that we have. But yeah, after all, it was all fun and pleasing. You know, we don't need to do everything that is very serious. Sometimes doing things for, you know, shits and giggles is also very, very fun. And yeah, as you can see, this works perfectly on the real hardware that I have a picture here. And I can also show you the real hardware because I have it on my desk. I hope you can see it. It's a little bit dark, but yeah, here's the Atari. And here's the old CRT monitor. And I can use joystick to pause the rainbow. Okay, guys, thank you very much. That's all what I have for you today.
Wow, thank you so much. Interesting stuff. Interesting stuff.
You're welcome.
Cool project. Super fun project. We have one comment from Ryan that he ran into a similar problem emulating 32-bit registers. Maybe Ryan wants to say more. And he has a question. I'm wondering if you could optimize enough a way to not to have to fully support 32-bit registers.
Yeah, just as a, I tried to do the same thing with WebAssembly, where instead of transpiling x86, tried to transpile WebAssembly bytecode into 6502 assembly, and I ran into the same thing. And I had the thought that maybe if I tried to do cross-program optimization to better fully understand the program as a whole, that maybe I would be able to get rid of having to use 32-bit registers, because you know, most of the time those 32-bit registers are not actually filled with 32 bits of information. And I'm wondering if you think maybe that's possible.
Okay, so actually I started with the version that was optimizing some operations that it could optimize, like using some native 8-bit instructions, but I encountered problems because the x86 code could treat the single register as 8-bit, 16-bit, or 32-bit. It can access separately different parts of these registers. So it turned out that the generated code was using the low part and high part of the register as different storage. And I get a conflict on the, let's say, Atari part. So I decided that the way to go is not to optimize early, just throw everything into the 16-bit, not 32, but 16 for simplicity, and then maybe optimize if I see the chance to it. But yeah, that would be like a different topic.
Okay, cool. We have two more questions from Sishan. One is if the inline equal sign is never required, if I read this right. And the second question is the put char API able to handle non-ASCII?
Yes, so the inline never is required just because if I don't use it, the function will be optimized away from the final binary, and the cargo ASM will not be able to find it and display the assembly. So this is like the trick for the optimizer not to touch this function and don't to optimize it out from the binary code. And regarding the put char, no, definitely not. It's not even able to handle full ASCII. It's only able to handle what is called ATASCII, like Atari subset of the ASCII character table. So we are only limited to what Atari has in its ROM with the font data.
Cool. Thank you very much. It's an interesting
No problem.
talk.
You're welcome.
Enjoy the rest of the meetup and your night.
Okay, thank you again.
So the next talk is from Sid, building a video on demand server to learn Rust. Sid, feel free to take over the screen.
Right. So, hello everyone. I'm Sid, just short for Siddhant. I am a TypeScript developer at Prisma, and we build developer tools for databases. So we're based here in Berlin, as am I. So good morning, good evening, wherever you are. Hopefully you're having a great day. This talk, though, has nothing to do with my employer. It's actually significantly higher level than the previous one, so hopefully it's still enjoyable for people here.
Sorry,
So,
Emma, could you check your microphone or sound? There's a clicking. Am I the only one who hears this?
I'm
I
using
heard
my
as well.
headphones. Is it very distracting?
Now it's better. Now it's gone.
Okay, I'm just gonna.
Okay, perfect. Thank you.
I'm not gonna move now. Okay.
No, don't move.
Okay, so like I said, during the day, I build web apps with TypeScript, but in the evenings, I'm a tinkerer. So I like to explore niche things. I like going down rabbit holes, and which is kind of where this talk kind of came from. And I like blinding people. So hopefully, now that all of your eyeballs are burnt, so in the past, I've experimented with mail servers. I built like a portable database thingy in Lambda, and did some very basic pattern recognition stuff with machine learning. So I'm usually a very private person, but I want to talk about things more. So thank you so much to Bastian and Ryan for being open and giving me a chance to do that. So this talk is about building a video streaming server to learn Rust. So like I said, recently I've been having a lot of ideas about exploring things that JavaScript isn't built for. And it's pretty high level as well. So I wanted to dig deeper into the stack a little bit out of curiosity. And I played around with a little bit of Go, with Swift, C#, but ultimately ended up with Rust. So I'm not going to give you the whole spiel of why Rust is awesome, because I think everyone here is pretty much sold on it. But I'm going to talk about the things that attracted me specifically to Rust, just really quick. So I think the number one reason why Rust was attractive to me was because of the ownership model. So I don't really do garbage collection in JavaScript like ever. I am deathly afraid of it, and the ownership model just helps me forget about it for the most part. So this is definitely one of the big reasons why I was attracted to the language. The second reason is the knowledge base or the learning material that's out there. So for someone who is extremely new to systems programming languages, all of the learning material that I found online did not really assume any prior knowledge, which was really, really appreciated. So anyone who has ever written anything about Rust, I really appreciate it. And the last thing that I really appreciate is the Dr.RS website. So initially, I didn't really like it very much. I found it very verbose to navigate. It was almost frustrating. But the more I started to learn Rust, the more I started to appreciate this website. So I appreciate that there's no real black box anymore. If I am confused about an implementation or something, I can always click on that little SRC link, and the black box just vanishes, and I kind of understand what's going on under the hood. Okay, so I've done a lot of talking. I'm going to dig deep into what this talk is really about. So I'm going to start with a little bit of explanation about what live streaming entails, and then I'm going to go into a little bit of code that I wrote. All right, okay. So videos on demand. So recently I started to get really interested in live streaming, and live streaming, just like Zoom or Twitch or whatever, and video on demand, which is VODs, or which is what Twitch calls them. So in an ideal world, the way you would stream a video from a server to a browser is you would have a video tag somewhere in your HTML, and the server would just automatically do it. Unfortunately, this does not work today. Obviously, what's going to happen if you do this today is that the entire video is going to be downloaded in the browser, and only then can it actually start playing the video back. Which means that if your video is a few gigs in size, or you were only interested in the first 5 seconds, well, that's too bad, because you're going to have to download the entire video before you can even start playing it. So I had no real idea about what I was doing. So literally my first search online was video streaming protocols. But over time, I kind of got to understand and got to realize that there's two major protocols that people use. One is RTSP, which is real-time streaming protocol, and the other is HLS. HLS is what I'm going to talk about today. I kind of picked HLS mostly because it was much simpler than RTSP. It's actually one of the first RFCs that I read from top to bottom, which is a big moment for me. So I'm going to really quickly explain to you what HLS really is, and then I'm going to jump to the code a little bit. So HLS at the core is extremely simple. Assume that this is one video file, like a timeline of a video file. The way it works is that you split this one video file into segments of 3 to 5 seconds each. It doesn't have to be 3 to 5 seconds. It can be any length as long as that length is defined. But 3 to 5 seconds is usually the convention that people use. So once you have this file divided, the way you play it back then is that you have a video tag on your client, and it downloads the first segment. It starts playing it, and while the first segment is playing, it starts downloading the second segment. Then once it finishes the first segment, it starts playing the second one, and it starts downloading the third one. And this just keeps on going until you reach the end of the video. Of course, it doesn't have to be as serial as this. While playing the first one, you can already download like 3 or 4 segments in the future, and that's what buffering really is. And the second part of the HLS protocol is something called a manifest file, which basically tells the order in which these segments are supposed to be stitched together. So the HLS contract is that, actually I'll get to that later, but basically there are 2 parts of the HLS protocol, which are these small segments of video files, and there is this manifest. Oops. Page up by default. Okay, so in order to build an HTTP server/client thing for this, these are the steps that we really need to do. We need to upload a file to the server. The server needs to recognize that that file is a video file, and then the server needs to start splitting the video file up into 5-second chunks. And then on the client side, then the client can request the stream manifest, which is this file right here. And this file will tell the client to start downloading the first segment, and then the client can start playing it back. And then while the first segment is being played, the client can download the next segment. And basically step 6 keeps on repeating unless you reach the end of the stream. All right, so I have a little demo here. Hopefully you guys can see this, but I have this little video here that is, I think, a Blender demo animation or something. I'm going to mute it if I can. Okay, it's just like a minute video, which is supposed to be for kids, but it's surprisingly dark for kids. But anyway, I'm going to use this as an example. So if I go into this video, you'll see that what I was talking about, these segments is what you will see here. So as you see here, these are like named sequentially, but they don't have to be. So if I open up the first one, this is like the first 10 seconds of the video or something. The second part is the next 10 seconds of the video, and this just keeps on going over and over again. And we have all the parts of the videos right here. And the most important, arguably, the part of this is the stream manifest file. So I'm just going to really quickly go over this because this is kind of important in order to understand it. So it starts with some metadata that we're going to conveniently ignore because it's not important or interesting. But after that, we have these sections that are 2 lines long. And each of these sections describe one segment that is playable. So the first line describes how long a segment is. So for example, this first segment is 10 seconds long, the second one is 1 second long, and it just keeps on going like that. And the second line of a section says that this is where you'll find this segment. So because it's called HLS or HTTP live streaming, this is supposed to be an HTTP endpoint. So the contract of HLS is that if the client were to send a GET request to this URL, it expects that.
Sorry, your clicking is back. Could you readjust your headphones?
Is it gone?
No.
Oh God. I don't know what's causing it though.
Do you have wired? Now it's back. Do you have like wired headphones? I mean, like it's not too bad.
I don't have wired headphones right here. Let me see if this will work. Let me see.
Now it's gone.
Okay, I think just plugging this in might have helped it. So I'm just gonna continue. If it gets worse, just continue, I guess.
Cool. Okay.
Okay. All right. So as I was saying, the HLS contract is that. Can I get rid of it? Okay. The HLS contract is that if you send a GET request to this URL, you expect a set of bytes that you can parse as a video. So this doesn't have to be a relative URL like it is in my case. It can be any URL, and this is kind of how Quiche also works. You have this manifest file that dictates how to stitch these things together. Okay, so now that we kind of understand what HLS is all about, it's time for a quick demo, and then I promise we're going to get into some Rust code really soon. So this streaming thing is kind of part of a bigger project that I'm kind of learning Rust with. And it's basically a web-based file browser, and it's supposed to be like a self-deployable Google Drive almost. So the idea is that you have, where is it? There we go.
Yeah, I'm sorry, but the clicking is back.
I don't know what to do about it. The thing is, if I connect this up, then you won't be able to hear me.
Now it's gone. Okay, I'm sorry for interrupting. It's just.
I'm sorry. I don't know what's causing this, but I hope it's not too distracting.
No, but now it's gone again. Great.
Okay, awesome. Looks like it goes away every 5 seconds. But anyway, all right. So this project is not really relevant. The idea is that I would upload a video file here now, and I will show you how that works. And then in the background, the Rust server will recognize that it's a video file. It'll start splitting it up, and I can show it to you in real time. So right here, you see it's basically a web-based version of this Explorer window right here. So I'm going to go into my videos, and I'm going to upload the same video file that I just showed you. So let me explain what's going to happen when I press upload here. It's going to go to this folder right here, and the Rust server is actually going to start splitting it up into segments of 5. So I'm going to do that. It's going to be pretty quick because it's not going through the internet. It's just like my local network. But once it does finish, you'll see that if I refresh right here, you see the video that just got uploaded, and then it has in the background started to split it up into segments. So as I refresh, you'll see that more and more segments show up basically as the video starts to get split up. So now if I go back here and start playing it, I can actually play the same video back just like before. And really quickly, if you look at this sidebar right here, you'll see that what happened right now is that the first request that went out, I'm just going to close this. First request that went out was for the playlist that I was just talking about. This is the stream manifest. And then every subsequent request, it's actually going out and fetching the video part. And as it keeps fetching more and more video parts, it keeps appending it to the end of this video. So right now, the video element thinks it's 44 seconds long, but as more and more segments get fetched, it's gonna keep on growing. So this is ultimately what I am trying to build. Is ultimately what I built. But now we can finally get into some Rust code and figure out what's actually happening. So hopefully you guys can see it. It's big enough for everyone to read. You don't have to read everything, but I'm going to go over the parts of the code that are kind of important. So this function gets called when you upload a video file. So I'm just going to skip over all of this authorization stuff. It's not important at all. What happens when you upload a video file is basically it copies the request body onto onto your disk, which is one of those things that JavaScript people like me took for granted. And only now that I realize that, okay, uploading is really just copying bytes from one stream to another. So it basically uploads the file. It starts to see that, okay, if this is a video file, if it recognizes it as a video file, it starts to generate these stream segments in a thread. Now, I am about 80
line here, but I haven't gotten to multi-threading in my Rust journey yet. So I'm just going to very conveniently ignore this. We're going to talk about what happens inside of this function right here. If I go inside of this function, you'll see that there's a whole bunch of stuff that happened before, but ultimately what it's really doing is that it's invoking ffmpeg with some list of arguments. Now, in the completeness of time, I want to replace ffmpeg and do something on my own. But for now, all that's really happening is that it's invoking ffmpeg with some commands and it's generating the stream for me. So using these two files, you now have the stream. Now let's talk about how you would actually consume the stream. So right here is the web page that actually gets rendered here. So this web page is actually this handlebars file right here. And as you can see, it's a very simple video tag right here with an ID, it controls, and autoplay is not relevant. The SRC here, unfortunately, has to come using JavaScript. And the reason for that is that HLS was created by Apple. So unfortunately, it is only natively supported in Safari. So in order to make it work in Firefox like I am, you need to have some sort of polyfills. It's typical lack of standards in the web, but you just have to deal with it. So the JavaScript, all it's really doing is that it says that if it thinks that the browser can play an HLS stream, it just sets the SRC to the stream SRC, whatever it is. If not, it does some other magic that is not relevant here. So I'm not going to talk about it too much. But coming back to Rust, now that we have this page rendered, the way you fetch a video segment or like a part of a video is also extremely simple. Because HLS in a sense is pretty simple. All you really do is that you read the files from the segment file from the file system into a bunch of bytes. You gzip it. You need to gzip it only because HLS expects a gzip response. And then you just slap on a couple of headers and you send the response back. And that's about it. That's all you really need to do in order to get to this beautiful video file or whatever. Yeah, so that's all I really had to show here. I'm going to go over a couple. Oh yeah, so this is the actual final ffmpeg incantation that works. I thought I might show it to you guys. It's a lot of arguments, but ffmpeg's documentation is pretty cool. So it's pretty easy to figure out. But anyway, just to close this off, I want to talk about some things that I learned, some things that I think I knew, but not really. So let's do that. So the first thing here is extending this project to live streaming is actually much more trivial than you might expect. So assume that you were to live stream and you were using like a software like OBS or something. So the way OBS really works is that it records your videos in 5-second segments, and then it uploads these 5-second segments to Twitch, and then or to Twitch or whatever, like to YouTube even. And then basically you can use the latter part of my setup to actually read this, these 5-second segment and then send it back to any browser that you want. So essentially all we're doing is that we're replacing the ffmpeg part of my setup with like a streaming software or something like that. So that might be one of those projects that might occupy me this weekend, next weekend. But yeah, if any of you is interested in trying it out, please give this a shot and let me know when you succeed. The other thing that I learned, and I'm sorry, I don't really know how to explain this correctly because I don't think I understand it completely yet, but I've noticed that there's a very stark difference in the way I do object-oriented programming in TypeScript or JavaScript and the trait-based stuff that I do in Rust. Hopefully in the next few weeks, I will understand what I'm doing a little bit better and I'll be able to explain what is different, but I just thought I'd put this out there in case anyone else finds this useful. So yeah, and this is the most important thing that I actually learned, is that sometimes it's the right thing or the sensible thing to not implement a trait. So a very crude example here is that I have these things called an absolute path and relative path in my code. The absolute path is the actual path of a file on my file system, and relative path is a path relative to some folder. And the reason these two exist is because I never want to leak out the absolute path from the server to like a browser or something. And the way I stop someone from doing that is basically I just don't implement the trait that converts it into like an HTTP response. Now this might seem very simple to a lot of people. I get that, but this was like the aha moment for me where I kind of realized, okay, I can actually use the Rust type system to help me in my security concerns or whatever. And yeah, that's all I really had for you guys. Unfortunately, I'm now on Twitter, so if you want to reach out, you can message me on Matrix or on Discord, or if you like the old-fashioned way, you can email me. I will respond to emails, believe it or not. The overarching project that I'm working on is nowhere near complete. It's mostly like a work in progress, extremely work in progress. But if you are interested, you can check it out if you want. It's also very poorly named, so it's nowhere near ready. But if you are interested, this is the link for that. So again, thank you for attending. Hope you guys have a great day. And thanks for Bastian and Ryan for letting me talk. Yeah.
Thank you so much, Sid. And I'm sorry for the clicker interruptions.
I am sorry about the
in the end.
I don't know what this is.
Oh, but it was a really, really cool talk. Do we have any questions from anyone? Feel free to send it in the Zoom chat or on Matrix. So far, there don't seem to be any questions. I think it was just so well explained that people are just, they get it.
I appreciate it.
One person said, I think GStreamer would be interesting to try out here. GStreamer RS.
Okay.
That's probably a great.
But I will give it a shot.
Okay, well, thank you, and feel free to come back with new side projects, and we will happy to hear and listen and watch. Oh, and there is 2 more questions actually. One question is roughly how much code was this whole thing?
The streaming code itself is actually not too much. I would say it's about 300 or 400 lines. But that also includes a whole bunch of other things, including authorization and stuff. I would say if you were to get rid of all of it, I'm just guessing here, it's maybe maximum 100 lines of code. It's not basically a lot of the work is done by FFmpeg, and all you're really doing is reading a file, uploading a file, splitting it up, and so on and so forth. But it's the code itself is in between a lot of other things, which is why it might look a little inflated. But yeah, it's not really a lot of code. If you understand what HLS really is, implementing it is pretty trivial, in my opinion.
Okay, thank you. And there is another one from Christoph. I want to know how much work FFmpeg actually does. Could it be replaced by just sending slices of the file, maybe prepended by a calculated header?
Yes, 100%. The only reason I use FFmpeg is because the experience that I was looking for is that if you upload a video, it converts it into a streamable format. But if you already have these slices appended, you can very well use those slices and basically change or write your manifest in the correct way so that it works without FFmpeg at all. So yeah, it's completely possible. It's definitely possible without FFmpeg. You know?
Okay. Another one is GStreamer RS. Is the GStreamer in Rust available ready, or these are just bindings to C library? I don't know. Like I think you don't know. Maybe
it's bindings to C.
Okay. C#, thank you.
No worries.
And one last question. The format is transport stream, right?
I don't really know what that means. Oh yeah, TS. Yeah. Okay. Yeah. Right. The format is TS. Okay, okay, I got it confused with something else, but yeah, yes,
Okay.
yes.
Cool. Thank you so much. And now to the breakout rooms. We have around 30 participants, 4 per room, around 4 per room. So I probably will make 3 to 4 people each room. We will have a 10-minute break, and then we will have our last talk. Let me. Jesus, how did this work? Breakout rooms here. Okay, I see you all. Let's say 8 after 8. See you later. Okay, everyone should be back now. And we have our last speaker for today. Can Daniel raise their hand?
Here I am.
Okay, I just made you a co-host, so feel free to share your screen and take the last talk of the day.
Sure. Let me see. Where'd it go? So I guess now you guys can hear me, see me, the screen and everything? Yes. Okay, then let me quickly start the presentation, and let me close the door. The talk is a bit noisy. Okay, so what do event sourcing abstractions look like? And the quick answer is, I don't know. So why am I, well, okay, first, who am I? Yeah, I'm Daniel Olano from Colombia, but I've been living here in Berlin for about 4 to 5 years. I was doing Go development like professionally for the past 4 years before the last year. And I got involved with Rust, like I was following Rust from very early, and then actually started doing side projects and coding a bit later. And relatively recently, I joined a company, like a startup that maybe I'll talk to you about later, which is kind of sponsoring me to play with all this stuff that I will show you. And the company is called Value. Is a startup, YC startup in Colombia, helping people to move money from Colombia to Venezuela, since the situation in Venezuela is quite difficult, and the company started to grow, and then now things started to get a bit out of control. We need to bring some stability to the system, some robustness, security, and so on, and we will be dealing with people's money, so it's important to make things fast, secure, and reliable. And then I've been helping, trying to like architect and set up how the system is gonna look like. So, well, I won't really go into details of what event sourcing is. This is quoted from, I forget this famous guy that wrote about this. But the main idea about event sourcing is that every change to your system, it's in the form of events. And every event, you are persisting it to storage instead of, like, say there is a user with a name, and then the user wants to change the name. Traditionally, people would just override some field in some database, and then the previous change is kind of lost. But with event sourcing, any change then becomes an event that is appended into a like traditional, like usually like infinite event storage that will hold the whole history of what has been going on with your application since you started writing events to it. It has some very good trade-offs, also some bad trade-offs, like so you have now a source of truth where the whole history of your company maybe is properly stored, and you can always check, go back in time and see what what happened, what was the state of certain entity at a specific point in time. And yeah, that's pretty much. I don't think it's really about explaining event sourcing, but then I'll say more or less why I got to try to develop an event sourcing abstraction. So it kind of it started with, yeah, in value, things are a bit messy. There's a monolith and then an attempt at microservices. Then I wrote a bit in Reddit a few months ago, I think, or weeks ago. It says there a month ago. Like a bit of an explainer of why value would need a Rust monolith to replace a microservice architecture, which is usually the opposite. Like you are always hearing how a company X moved from their monolith to some microservice architecture. The issue is that, like, to sum up, I think the team is quite young, and in value, like, yeah, sure, we started like make everything a microservice, but some domains were not clearly defined. There were a lot of dependencies. So there was a big awful monolith plus now some awful microservices, and a lot of interdependencies. If one service is down, everything is down. No monitoring, no logging, no tracing, no anything. So sometimes something randomly breaks in one part and then everything collapses. So I propose, like, let's step back. Maybe we don't need these microservices anymore, or like yet, at least. Let's focus things since the company already bought into the idea of developing things in Rust. Then I decided to do, okay, let's do Rust, but let's do things, try to constrain ourselves in the way our different domains interact with each other, and how yeah, and how we can avoid as much as possible to shoot ourselves in the feet. So I introduced the concept of end-sourcing and CQRS. For the ones that don't know, CQRS stands for Command Query Responsibility Segregation, which means that it's a pattern, a design pattern that goes very well in hand with the event sourcing. Like, it means you separate anything that mutates the state of your system. You separate them from the querying, like anything that is data retrieval. And so the commands that are meant to mutate the state of your system then becomes, like, when you mix it with event sourcing, these commands translate easily to events that then are persisted to some storage. And on the side, you can build like aggregations of these events, and then have like maybe separate caches or storages where you have the aggregated, like the view of your entities. Like, if you have a series of events, you just sum them up, see what it's like, take a snapshot of a certain entity at a specific point in time, and then return that. Like, there are many ways to do this event aggregation and then have a proper query interface, which maybe we'll talk more. I'll look, part of this talk is also to discuss maybe openly, like, what do people think about this kind of abstraction, and what ideas do you guys have to make it better, and well, and so on. So how it started, I said, like, okay, let's do event sourcing. As usually, I just go GitHub. When I'm looking for a topic, I would just do this advanced search, event sourcing, language Rust, and see what I find. And surprisingly, there was not much. Well, not surprisingly, I guess event sourcing is more of a pattern. No? It's not like something you usually comes in a framework, in a ready to use library. There were libraries, didn't really find much. But then I stumbled on, then I crossed Ricker, which is an actor framework. And actor-based systems are also very attractive to me, since they enforce this pattern of actors can never share state. They communicate with each other by passing messages, like sending messages. So when you want to put a lot of microservices, replace them like with a monolith, it's a pattern that makes a lot of sense to have like an actor framework that where you define your domains, your entities, and then they are not really sharing state, because that's often what kills monoliths, like this interdependency and how you touch something in one part of the code base and then everything breaks somewhere else. So I said, yeah, I'm all in for actor frameworks. There's not much in the Rust ecosystem, I think. There is Actix. I think it's the most famous one, but it's very focused on the web framework. Like before, they had it separate, but then when looking back for just the actor framework bit, it seemed like maybe it's everything together now. I don't know. Also, Actix is known for not being, or maybe some other people are maintaining it, but the creator said that he didn't want to maintain it. This project seemed a bit stable enough, like has been there for a while. And then I also see that supports event sourcing and CQRS. So I was like, cool, this is definitely what I need. But it wasn't quite there yet. So they have, like, for example, this repository under the organization. But then I see that it's not really, it's like just one file that, in the source is there's just this one library file that hasn't been updated for a while and is dependent on changes of an older version of the framework. So it's not really, wasn't really up to the task, like I couldn't do much with it. So, but I had already started like investing time on it and say, no, it looks fine. Like Ricker as a framework seems like a good solution for the problems I might face with value. So I still kept Ricker, but then decided to go on the adventure of trying to create an event sourcing abstraction. So this is what I came up with. So yeah, so it's not only about event sourcing, but also about CQRS. The idea I had is like most of my abstraction is around this concept of the storage, like having a generic trait that and a sync trait that different backends can implement, like say a in-memory backend, like using RocksDB, SLED, or SQL database. So you implement the trait, and then you have like each entity separately. Say I have in one domain users, another have I don't know, transactions or something else, and then each domain can define their own storage, which can be one uses the in-memory backend, the other one uses the SQL backend, or even a blockchain backend. So this storage abstraction is the one that which actually then I changed because in one of the tasks that the challenges that I'm up to in Value right now is to blockchainize the product, since for what we're doing it makes a lot of sense. So we're building a substrate-based chain that I'd like to have here like as one of the possible backends for the stuff that needs to go in the blockchain. This can go. So if I see my events in the storage, not as events but as commits, I call them. A commit has you can know who made this change, why they made it, like similar to Git, and maybe eventually like a signature, like maybe signing the change or even referring to a parent, I don't know. And then have like a future blockchain framework, I don't know. No, gracias, no. So yeah, I have the commit store, this abstraction, and you can also query, take a snapshot of an entity from this abstraction. It returns a handy time traveler, I call it. I'll show you guys later. And it allows me to take one entity and fast forward it to a specific moment in time and see what was the state at that time. This layer of the storage implements the actor trait of recurs. So these two layers will be actors that will talk to each other using the recur event like a message passing system. So it means that here my handlers, they will be processing one message at a time. The framework provides this because it's an actor framework. It's very handy that I know that I will be getting one message at a time. I know that if something goes wrong, like if it crashes, then it will be brought back to life and keep processing the messages that it couldn't process before. And once the processing is done, it persists. The idea is that the command or event handling will produce an event that gets transformed, like an event or a commit that gets sent to the storage to be persisted. Also in this layer is where we do the model definition. Like I say, this is my entity with my properties, and then I'll be persisting this. So a command enters. There's some command handling here. It returns an event. So sometimes people broadcast events from this layer, like from the command or event handling, but I thought it would be, or at least for my needs, that you broadcast the event only after you successfully store it. So this also makes the design a bit simpler. Just handle your command, return an event, the event gets persisted, then it gets broadcasted to this. I made a mistake. So it's not event store, it's the event bus. And the event bus will broadcast events that other entities can listen to and then handle those events and so on. So you have like this life cycle there of commands arriving, events being stored, events being broadcasted, other entities listening to those events, reacting to those events, and also changing its internal state by producing commits. So enough of this talk, and I will quickly, where did it go here? Okay. So maybe I'll make it a bit bigger. this is like maybe the heart of the library. It's the trait for storing commits. Right now is just this simple thing that allows me to commit something. I can get this like a stream of commit results. So I can get the keys that I have persisted. This gives me like the set of changes for a given entity, like it passes the entity ID. And then I get like all the events for that entity. I make a difference between, so if we see the event abstract, okay, I'll show you later the event, but then an event can be like a created event or an update event. And the create event is like the full entity in its initial state. And then the update event is user defined, and the user will choose like what are their updates. Like for a user, you as a user will say change birthday or whatever you want to define, and then you'll handle those. So it has this utility method to like get a specific entity by ID, like already with the changes applied. Well, actually, if you see, it doesn't come with the changes applied, but for performance reason, like every time I'm gonna get an entity, I don't want to always do the snapshotting, but make it like time traveler is like a way to make this snapshotting lazy. Like only until I really need it, I would do the aggregation. So when I get an entity, then I'll return that, and then later with the time traveler that is somewhere down here. Okay, for example, you have this snapshot method, which is just the get, and then I tell it travel to this specific moment in time. This travel to is a method of the time traveler. It's around here. So I can, it just has this. The to present is just a shorthand for going to the current time. And then I just apply the changes. This apply change here is a method that was defined in the model. Like in your models, you would define, like you as a user, only you know how to apply certain changes. So I'll show you how that might look like. But that's pretty much it. So you have, when you want to implement a backend for the commit store, you just have to implement these methods here, these methods here, and then also the end user, like this is just for the backend implementators, but the end user will actually I decided to make it kind of restricted. So the end user will just deal with the entities that I'll show you next. And they actually don't even have access to the storage. They just return the commits that will be persisted, but they don't even have access to the storage. What else do we have interesting in this file? Okay, yeah, there is this implementation that comes from Ricker, which is the trait that implements actor for store. Another thing that was not so convenient when I started using Ricker is that since it dates from before this async Rust, then it's not, it has support for async functions, like it allows you to spawn an async task, but it's not super ergonomic, I would say. So also that's kind of why I have this trait that comes with this async function. So if your backend is, for example, the SQL backend that is already async, then it becomes much nicer to implement that backend if you have to implement an async function than to do all what the recur framework does. Like, so initially I started with the from the recur point of view, but then I started building these abstractions like the store and the entity to kind of hide away the framework and maybe eventually not have the need for recur in case I might want to explore changing the actor framework that is underneath. This is the, so okay, what, let me see this way is a bit better. That way now. The same file. This is the entity trait. So this is for the end users. The end user basically just has a bunch of associated types. And they would say like, okay, I define like the generic type of the arguments that will be passed to this sort of constructor. This is part of the trait because I will be passing the recur context to this constructor, and then the user can like create new actors and communicate, like hold reference to other actors in the system. If also like they don't have to be limited to just using these entities, but like you have some random actor created with recur, then you would be able to create it here or reference to it if it already was created, and then send messages to it. And it's just basically, it's just this, it's just handling the command. So you receive the command here, which is generic. So as a user, you will see like, what are my commands? Like usually it would be an enum where you say, yeah, my entity users has the command update name, update birthday, and so on. And you just have to return me a result that is just a standard result where the OK value is a commit that is generic over the model here that is defined that you defined as a user. Also, the error is generic. Like hopefully later when the default values for these associated types is available, then I will also already like give maybe some error type by default or some argument by default like empty. So then you have to implement less things. Here I'm also implementing the actor trait, and then the actor when creating the actor is when I instantiate the store. So the entity is generic over your like the implementation of the sourcing trait, and also generic over some storage. So I will instantiate the storage for you. I'll hold it there in the entity actor internally, but you really don't have to care about, like later I'll show you also from the user's perspective how it looks like. And when I receive messages, I can receive queries or commands. Right now the querying part is super crude, like it's really flexible. You get one entity or you get all the entities. But there's I'm thinking I'm also open to suggestions and how to implement a proper a querying abstraction. But it's hard because I have experiment a bit, but it's hard to create a proper query abstraction that then, for example, an SQL backend can implement. It just, I think it's very error prone, and so maybe I will just let the query be backend backend dependent, so non-generic. And in the commands, in the context, I have the access to the executor that Ricker uses, so I can spawn the futures. So I spawn some future, and that's where I handle the command that the user defined. Yeah, when it comes to the entity, that's pretty much it. For example, here's an example of this struct is the. No, wait a sec. No, I'll show you some other example better later. Okay, and to kind of to finish to wrap everything up, then those entities, people start defining their entities, and then you want to have a way to route commands and queries to the right entity. So I have this entity handler, entity manager, I mean, and the entity manager is easier to show here the signature. You just create it based on a Ricker actor system, and then you register your entities just by saying the entity that you just defined, kind of to hide away the instantiation of the Ricker actors. It's just kind of a layer to hide away a bit the Ricker setup. So I register entities, and then I can issue commands and queries for those entities. And it looks a bit like what is here. You instantiate your entity manager, you register some entities where I tell it, this is my entity, this is how it looks like. So if you see, the entity one is just this struct, this is my model, but it doesn't actually hold anything useful. No, that's the entity, sorry. And the model is the model, of course. And the model says what is the type for the change. And when I apply changes, I will receive that change that I define here. And then that way I take a mutable reference to self. So when a change arrives, it gets applied to the current object. And when I handle the command, this is what I usually have to do. I return an event. I still haven't done much with the commit concept, but so that's why I can usually an event turn it into a commit. And by default, it will be then no one did this commit, and the reason will be also an empty, a void value. Yeah, I think that kind of covers this abstraction, and then I'm still
5-minute warning.
Okay, so yeah, I actually I won't go and show you more, or maybe let me see if values. I'll quickly just show you more or less how it looks when I use the library. This is like code that is being tested now in Value, like it's still just a work in progress, not in production yet. I'm defining certain entities with like this account, transfer, invoices. And for example, this was the first proof of concept that I started implementing this for, which is showcases also like how helpful the actor system might be. In the invoice is here. Just when I handle the command, it just generate this invoice for certain transfer, and I will send a message. I will do this capture, and this is talking to a web browser behind. So I know that because of the actor system, I will only be sending one thing at a time to the browser. I don't have to deal a lot with the concurrency there. And yeah, so far it has been proved helpful. But yeah, I won't go farther than this. And I will just continue to the presentation, which is just concluding that. Thank you. And yeah, this is more or less what I'm up to in Value right now. Since they are my sponsors and letting me play with all this Rust and mess with their infrastructure and now this blockchain stuff, like a lot of things coming to Value. If people are interested, also we are welcoming Rust developers. Now, I guess for the questions.
Thank you so much for your talk. Very comprehensive, very informative. Thank you so much. Any questions? I'm checking Matrix and the Zoom chat, and there are none so far. So this is your last chance. Nope, doesn't seem like people wanna ask. I'm quite sure they might get in touch with you once they have a burning need. Okay. Yeah, people really liked your talk. So again, I thank you so much for presenting here at Rust and Tell. And this was it, people. This was our September meetup, and we will be back next month, always the last Tuesday of the month. Feel free to submit any talk, any idea, anything you want to talk about. We can also help you with organizing your talk or getting the right content. Just approach us. Any last words, Ryan, from you?
Nope, it sounds all good. Looking forward to seeing everybody next month.
Okay, cool. Well, then have a pleasant night, and we see you all next month.